In this chapter, I will tell you the technique and strategy on how to master the differential calculus. First, you must know the basic rules of differentiation: the power rule, the product rule, the quotient rule, the derivatives of trigonometric functions, and also the higher derivatives.
So, submates, so today we are going to answer these two basic transcendental functions. Before we answer these two questions, we must familiarize this so that it will be a lot easier answering these questions. Reminder, this is just a short recap on how to derive these functions. So, let's start.
So in the equation y is equal to sine 5x, we're gonna determine first what is the derivative of sine. So as shown in this table, the derivative of sine is cos times the derivative of du dx. So here we're gonna write the cos, the derivative of sine, so here is cos u du dx. So the du dx is the derivative of 5x. So with respect to x, the derivative of 5x is 5.
After taking the derivative of sine, which is cos, you're going to plug in the derivative of 5x, which is 5. So it will become cos 5x times 5. Since 5 is the constant value, it will remain as it is. 5x is the u. And the derivative of 5x is 5. So it's cos 5x times 5. To further simplify, you're going to multiply cos 5x times 5. And it's going to be 5 cos 5x. And that would be the final answer.
So here is another equation of basic transcendental function equation. So in the equation y is equal to tan 3x squared, we first again determine the derivative of tan. So the derivative of tan is sec squared u times du dx. So the derivative of 3x squared, which is the constant value of u, is 6x.
So we have already taken the derivative of tan, which is sec squared u times du over dx. So we're going to plug in the u, which is 3x squared, and then it will become sec squared 3x squared and times it to derivative of 3x squared, which is 6x. So by multiplying sec squared and 3x squared times 6x, the final answer is 6x sec squared 3x squared.
Here we go again. Now, I will teach you how to do and solve exponential and logarithmic functions. But before that, you must familiarize this. The derivative of trigonometric functions, which is the sine, the derivative of sine could be cos, and the derivative of cos would be negative sine, and the derivative of tan is the sec squared, and the derivative of cotangent would be cosecant squared, and the derivative of sec is the sec times tan, and also the cosecant would be the derivative of negative cosecant times cot. Now, if you familiarize all of these, all of the trigonometric functions, I know that you can easily understand and answer all the problems of exponential and logarithmic functions. Now, as we proceed, I will show you the new formula of exponential and logarithmic functions, which we have now. Now, d over dx is quantity of e to the power of u, would be e is form of Euler's number or equals to e to the power of u times the derivative of du over dx. Now, if you encounter this kind of exponent, you could use this formula as your guide to solve the problem. Next, d over dx, quantity L and u is equals to 1 over u times du over dx. Now, your u here could be the side of ln if there is a problem that you encounter. Now, I'll teach you later to solve how to solve natural logarithmic functions. Next is the log times subscript of base x is equals to log a or alpha x over log alpha base. Now, you have to familiarize and memorize this because this is very important if you encounter problem of exponential and logarithmic function. Why? It is because this is your guide on solving the problem that may you encounter. Now, don't worry, I also have a sample problem here to show you how to solve the problem of logarithmic exponential function. Now here, problem 1. d over dx ln quantity cotangent 2x. So if you encounter this, you can easily identify that you may use this kind of formula. The second one here. It is because there is a natural logarithmic, so you can easily identify what formula you could use to solve this problem. Now, are you ready? Okay. And now we're back. So, as I said, the formula that we have to utilize are the second formula, which is d over dx quantity ln, or the natural logarithmic, times u quantity is equals to 1 over u quantity, the derivative of du over dx. Now, if you get the given here, we have to refer our formula which is u, just copy the problem, which is ln, quantity cot 2x, and then the derivative of du, which is du over dx is equals to. So here, as I said, you have to familiarize and memorize the trigonometric function so that you can easily solve if you encounter identities, so that you can easily solve this problem. Now the derivative of cot could be the negative cosecant squared, which is here, the cot negative cosecant squared. Just copy all of this, 2x times the derivative of 2x could be, it is constant, 2 times 1 be 1, 2 times 1 could be 2. Now, to further simplify this, our derivative du for dx, you could easily find the final answer, the negative 2 cosecant squared quantity 2x. Now we already have our derivative of du and over dx. So now we already have the given problem so that we can easily substitute this to our formula. Solution: d over dx is equals to, copy this, 1 over u, so that you have the guide so that you can easily substitute this given formula or the given problem, so that you can easily substitute this dx. Next, calls 1, substitute this function to u, ln cot 2x times the derivative du over dx would be negative 2 cosecant squared quantity 2x. Negative 2 cosecant squared quantity 2x. Now, you already now have the answer, but for us, you can also have to simplify this equation. So 1 times negative 2 cosecant squared quantity 2x, you just copy this and you have to put this in the numerator. So you now have the simplified form of this equation. Negative 2 cosecant squared quantity 2x over, copy, ln cot 2 quantity of 2x. Now, this is your final answer, that simplified form to this equation. Done. Now that's problem number 1. We solved this problem earlier, just has the answer of negative 2 cosecant squared quantity 2x over ln, or the natural logarithmic cot quantity 2x. Now this is just now the simplified form of this problem. Now next we have to solve this exponential. Now if you ever wonder why this happened, now I made this problem to have a twist so that you can so that if you ever encounter this kind of problem, you can easily find a way to solve this. Now we're back again to solve this second problem. First is to find the formula. Now, as you observe, there is an e variable here, so conclude that we could use the first formula, which is this: d over dx quantity e power of u is equals to e u quantity du over dx, or the derivative of du over dx. Just copy that. EU quantity du over dx. Now we have the first formula. Now, as you observe, there's a two quantity here, so we could apply the product rule. Has the formula of product rule to the second times the derivative of first plus, or addition of first the derivative of second, so that you have now this kind of formula, which is dy over dx is equals to second times the derivative of first plus first derivative of second. Now, the next part we'll do is to find the given, so that we could easily answer our equation. Now, find the given. Now, the given here are the first derivative in the product rule, because first we should apply the product rule so that we can easily answer this kind of problem. Now, here, the given here, the first derivative is equals to, or the first equation could be cos 5x. Second, the second equation would be the e to the power of sin 2x. E power of sin sine 2x. Now the derivative of first. Now, here, as I said earlier, you must familiarize and memorize all identities, or the derivative of trigonometric functions. Now, to understand more, the derivative of cos could be negative sine, as you can see here, or formula. The negative sine u would be the derivative of cos, so we should apply this. Negative sine times the derivative of 5x could be 5, so negative 5, copy the derivation of cos could be negative sine, or here's the negative, then copy the 5 derivative of 5x, put it here, sine 5x. Now, the next one, you must find the derivative of second. Now, here we could apply the chain rule, or should apply this. First, let's find the u. This u, the second derivative could be here, and you must find this equation. E sine of 2x Find the derivative of e, the sine of 2x, be this. U be the given. U is the outer. What is your outer? This is outer is sine of u. The derivative of sine 2x could be the cos 2x. Cos 2x. And your outer could be the derivative of 2x. Be your 2. Now, should say that our formula here. Copy this solution. Just copy this problem. Y over dx equals 2. Copy, so because as you can see, just copy the e, and our u here is the sine. Actually, this is derivative of u, derivative of I, and our u and your I, 2x, and then sine 2x. E, copy this formula, sine 2x. Now the derivative of u, cos 2x times the derivative of I could be u. Now we already have this derivation of the second equation. I'll put it here where you can put it. E sine of 2x times cos 2x times 2. Now, as our solution, we now start by applying a product rule to create an answer and find a solution. First is apply this formula of product rule, which is the second derivative, or the second equation, be e. We should quantity this e sine of 2x times the first derivative, which is the first derivative, negative 5 sine 5x quantity. Now just add plus first, which is the cos 5x, cos 5x times quantity, or rather quantity, put quantity to the, it will signifies that if you have a quantity, you must multiply it, times the second derivative, which is this e sine of 2x cos quantity 2x times 2. Now, first we'll have to simplify this form so that you could have a standard and qualified answer to your professor. Now, e sine of 2x times negative 5 sine of 5x will be the result of negative 5 wait, negative 5 times this. Negative 5 times times e sine of 2x could be negative 5 sine quantity of 2x, 5 sine negative 2x, so it has an e, times the sin, which is this, sin quantity of 5x, which is this, plus 2e times this, 2 times e equals to 2e, copy this exponent, sine quantity of 2x times cos this, just this, times cos 2x, and then actually 2 times e sine of 2x is here, and just copy this equation, which is cos 2 quantity of 2x times copy the another one, cos quantity of 5x, so that in simplified form, or in other way, your answer is 5e, or the exponential sine 2x times sine 5x plus 2 exponential sine 2x cos down cos 2x, and also cos 5x. Now we now solved the second problem in the simplified form. Okay, because we solved now the second problem, which has the answer of negative 5e sine of quantity 2x sine of 5x plus 2 e sine of 2x quantity 2x cos of 2x, and also cos of 5x. Right, now the answer of the second problem. Now I suggest that you can easily answer this if you familiarize the derivative of trigonometric and also their formulas of exponential and logarithmic functions.
Hello everyone, let's solve this equation. Now in solving this equation, apply the differentiation rule. Note, the chain rule has been applied here, multiplied by the inner derivative. So let's multiply sine times square root of ex plus a over 2. And here's our formula. The formula is sine, the derivative of sine u times ex equals to cosine u times x times u prime x. Now let's put our equation. So the derivative of sine is cosine, and then copy the inner function, which is square root of ex plus a over 2 times the derivative of the inner. In deriving the inner function, the differentiation is linear. We can differentiate someone separately and pull out constant factors. Now let's separate square root of ex plus a and the over 2. And here's the function. 1/2 times derivative of square root of ex plus a is the separate function. Now we can differentiate this function. Now in deriving this function is we will use the apply the power rule. Note the chain rule has been applied here. Multiply by the inner function. As what we have used in the first step, we will multiply first the outside and then the inner. So here it is, 1/2 square root of ex plus a raised to 1/2 times derivative of ex plus a. Now the power 1/2 is, this is the other form for the square root, and then copy the derivative of sine, square root of cosine square root of ex plus a. Now, and our function has sorry for the technical difficulties. Now let's cancel out the over 2, and cancel out over 2, we will divide this by 2. Now after cancelling this, here's our final equation. So the derivative of ex plus derivative of x, derivative of a times cosine square root of ex plus a over 2 over 4 square root of ex plus a. Now the next step is we will derive this equation. In deriving here in this equation, we will follow the exponential rule. So the exponential rule for the derivative of ex is ex, and then the derivative of a is a constant, so it is automatically turned into 0. And then here's what will happen. So the derivative of ex is remain as ex, and then the derivative of a is equals to 0 times the derivative of sine is cosine square root of ex plus a over 2 over 4 square root of ex plus a. Now I know you are wondering where do 4 square root of ex plus a came from. So it is came from this equation. Now square root of 4 ex plus a comes from here in this equation, because in deriving this one, the exponent 1/2 will be less than by 1. So the result here is 1/2 times ex plus a raised to negative 1/2, and then the exponent is 1/2, so we need to put it as a denominator for this fraction so that it will become positive. Now answer for that is 1 over 2 square root of ex plus a. Now the other function is we have a 2 here, so we will multiply this by 1/2, so which will become the result of 1 over 4 square root of ex plus a. So that's why we came up with this equation. And then after that, we will distribute cosine square root of ex plus a over 2 to the ex plus 0. And here's our final equation.
So that's all for today. Thank you. God bless.